Find the interval of convergence and radius of convergence of the series sum n equals 1 to infinity, negative 1 to the n, the quantity x minus 5 to the n, all over 4 to the n, and the cube root of n plus 1. We use the ratio test. Find the limit as n goes to infinity of dividing successive terms a sub n plus 1 divided by a sub n. What we do to simplify the algebra is we make a fraction for each of the individual terms, a grand total of 4 terms, where we substitute n on the numerator, replace every n by n plus 1. Each separate term gets its own fraction. And then in the denominator, we have 4 to the n plus 1 and the cubed root of n plus 2. In the gaps, we put the associated n terms. Since we're dividing by a sub n, things that were in the numerator end up being in the denominator. We take the reciprocal. And so this is a way to skip through the algebra. Totally not a necessary step, but it helps. So we take each individual limit, simplifying by peeling apart negative 1 to the n, factoring out a negative 1, factoring out an x minus 5, factoring out a 4, allowing us to cancel negative 1 to the n with negative 1 to the n, x minus 5 to the n with x minus 5 to the n, 4 to the n with 4 to the n. Leaving us with a negative 1, and x minus 5, a 4, and this last limit here is simply just going to go to 1. The plus 1 and the plus 2 become insignificant as n goes to infinity, and so that 1 ends up not really playing a role at all. We have the limit as n goes to infinity. Actually, all the n's are gone now. We have the absolute value of negative quantity x minus 5 all over 4. So the limit is already performed. There's no longer n involved. We need for this to converge, so we need to force it to be less than 1 in absolute value. Pull off the 1/4 and have the absolute value of x minus 5 less than 1, or the absolute value of x minus 5 multiplying both sides by 4. It's less than 4. So this is an interval centered at 5 where we go 4 in each direction. Add 4 to the right, take away 4 to the left, giving us 9 and 1 as the endpoints. Once we've isolated the x minus a term, we have exactly the radius of convergence on the other side of the inequality. So we have the radius of convergence is 4. That's what gets added and subtracted to a to get the interval of convergence. And now we just check the endpoints. At x equals 1, we're going to have summation n equals 1 to infinity, negative 1 to the n, and we're going to plug in a 1 into the x minus 5 to the n. That's all over 4 to the n, and we have the cube root of n plus 1. And all of this here will combine, this guy being a negative 4. If we all put it to the n, every one of those things, we have negative 1 times a negative 4 all over a 4 whole thing to the n, that just simplifies to 1 to the n, which is going to just end up simplifying to be 1. And so, the only thing left then is the cube root of n plus 1. And what we could do is just state that it is similar to a p-series, the plus 1. We could do a limit comparison test, but we'll just say that it's a divergent p-series. Our b sub n is 1 over n to the 1/3, and by the limit comparison test, if we take a sub n and divide it by b sub n, we get 1. So they behave alike. So a sub n also diverges. The other endpoint, x equals 9, n equals 1 to infinity, still alternating, negative 1 to the n, and now 9 minus 5 to the n, all over 4 to the n, and the cube root of n plus 1, gives a negative 1, this time times a 4, all over a 4, whole thing to the nth power, and we end up with the alternating sign this time, still with 1 over the cube root of n plus 1 also in there. And so this simplifies then to be the alternating and that's going to be by the alternating series test. This time the b sub n is dropping off the alternating term. It's decreasing. You can check it by taking the derivative. It's decreasing and its limit is 0. As b sub n, as n goes to infinity. And so by the alternating series test, it's convergent. It's one of those conditionally convergent series. Okay, great. Divergent on the left, convergent on the right. So this interval, for the answer to the question, try to fit it down here. So the answer to the question is divergent on the left, convergent on the right. We use a square bracket for convergence and a parenthesis for divergence, meaning that if x takes on any values in that interval, then the power series will be convergent.